Welcome to this session. I hope you all enjoyed the superb keynotes this morning. My name is Prem Natarajan. I'm a vice president in the Alexa AI organization. I'm here with my colleague, Michael Kearns.
Hello, everyone. Good morning. I'm Michael Kearns. I am an Amazon scholar, which means I divide my time between Amazon within AWS and a faculty position in computer science at the University of Pennsylvania.
Michael is being modest. He's also the author of a widely popular academic book, The Ethical Algorithm, which is very relevant to the topic at hand today. Okay. I won't start the introduction again, save you some time. Our vision at Amazon is to make AI useful for all our customers, all the end users of AI worldwide. We do this by driving a vision and driving towards the manifestation of an environment that we call ambient intelligence. By ambient intelligence, we mean a set of AI services that are available to you everywhere. You can access them when you need it. Sometimes they might even anticipate what you need and suggest it or do it for you. But they also fade into the background when you don't need them, right? And both across, sorry, this thing is trigger happy. Sorry about that. So, and building fair, inclusive, and accessible AI is central to achieving this vision for ambient intelligence. Our customer base is global and it's diverse. Billions of customers interact with our AI services on a weekly basis. Billions of interactions across all of our devices, hundreds of millions of Alexa devices worldwide, and we are in more than 70 countries worldwide. Now, the question is, how do we make AI equally performant and uniformly accessible for such a broad, global, diverse base? I promise you I'm not clicking it. So how do we make progress towards that goal? The approach that we have adopted is a multidisciplinary one that tackles the many different challenges that stand in the way of achieving that vision of equally performant, uniformly accessible AI for everyone. The first pillar of that approach is an inclusive AI design. And I'll go through a couple of examples that show you how we think about inclusive design in AI. The second is one that recognizes that the hardest challenges in inclusive and accessible AI are ones that are beyond the capacity of any individual organization, however capable that organization might be, to solve. And so we seek to harness the talent that is resident in academia and industry worldwide towards addressing some of those challenges so that we can all collectively build upon those advances. The last are the advances in AI ML that are required, the new inventions that are required, the new insights that are required to make AI more equally performant, more uniformly accessible, and we'll go through some slides on that as well. So the first pillar, inclusive AI design. So many different experiences that are delivered to so many different user cohorts. How do we make all of that inclusive? Now, the first step towards that is to remove access barriers. 1.3 billion people globally face some kind of cognitive challenge, whether it's with dexterity or with processing sensory information input. Nearly 30% of US households have somebody who faces a challenge. Right? Many of these challenges are to do with hearing, with vision, whether it's disfluent speech or limitations in hearing or vision, et cetera. And the prevalence of these challenges increases with age. Right? So we need to building AI services that can address and overcome these challenges is an absolute must. We must build AI services to solve for the needs of this growing cohort of users. And we think good design with accessibility will not just improve performance for these folks with challenges, but it will improve performance for everyone worldwide. A classic example of this is the sidewalk cut. Most of us know about the curb cut on the sidewalks. That was actually an innovation, believe it or not, that came out in 1945, post-World War II, for veterans with challenges who couldn't access those curbsides. But now everybody with a wheelchair or a kid in a wheeled carriage benefits from it. So that's the nature of these advances. They help everyone. These challenges can be permanent, like people may not be able to speak. They may be transient, as in you have a throat infection and therefore your speech challenged for a short while. It may be situational. Your baby is sleeping, so you don't want to talk loudly. It can also be preferential. You just prefer touch over voice, or you prefer voice over touch, and other such things. So how do we unlock? So for all of these folks with challenges, a key goal they all share, a key desire they all share, is the desire to be independent. And our efforts towards making Alexa more inclusive and more accessible are targeted towards unlocking this independence for these users, motivated by the same thing that was behind the sidewalk curb cut. These efforts span accessibility features that you can see on screen. Alexa captions that help people who may not be able to hear read on screen what's being said. Show and tell. This is for people who might be vision challenged, who can hold up things to an Alexa device with a camera and have that device read out to them what's on that thing. Mobility, speech use. Hopefully many of you were at the keynote and you saw the Astro robot. That helps with mobility challenges and voice interfaces with that. Voice control of Astro helps. But there are also other things like routines, drop-in that helps you stay connected with your family. And the last one is speech. Blind customers, for example, prefer a faster speaking rate because that's their primary way of acquiring information, and they want that information to come at them faster. Other folks, especially older folks, prefer the speaking rate to be slower. So how do we make all of that and CX more inclusive so that it can adapt to these different users? All of these are part of an inclusive AI design. Alexa Together is an example of how all of our efforts in designing more inclusive AI is delivering direct benefits to end users. As a result of the longevity revolution, number of seniors worldwide has grown substantially. People are living longer, and we want those longer lives to be more fulfilling for everyone. An inclusive, accessible AI can have a transformative impact on these folks' lives. Alexa Together was launched in December 2021. You saw that video show you some of the features in there. I'll skip over to the next slide and show you. Anecdotal feedback from early customers and from analysts reinforces the key value proposition of Alexa Together, that of an AI-powered caregiving service that brings peace of mind, helps you stay connected with the loved ones that you care for without having to be physically in the same location as them. Right? These kinds of feedback inspire me and many of the scientists and engineers and product managers and everyone working on these features in our organizations. Moving on, I'd mentioned to you how we see partnership with academia, the diverse talent resident worldwide in academia, as crucial to solving some of the hardest challenges in fair and accessible AI. So we started off this partnership. We recognize that the National Science Foundation, at least in the US, is the premier funder of academic research efforts. So we said the best way to maximize our outreach into academia is to work with the National Science Foundation. So we decided to partner with them. We created a program called Program on Fairness in AI. We launched it in 2019, focused very computational, advance AI in a way that we can advance the solutions that are being delivered to end users worldwide by everyone. $20 million in funding, equally from Amazon and from NSF. We left the selection decisions entirely to NSF so that the agenda is defined by the academic community, not by any single organization. So we don't even review those proposals. The proposals are reviewed and selected by NSF's peer review panel. So far, we have funded 70 faculty-led research efforts across 40+ universities. The program is going strong, and we're starting to see some outputs from it. About 40 papers have been published that put new insights and technologies within reach of a lot of the folks who are working on these things worldwide. In addition to directly supporting research initiatives in academia, we're also working with academia on initiatives to enrich the diversity of the national STEM talent pool. Because we know that the inventions that we make are only as good as the diverse perspectives that are represented in developing those inventions. So the Summer Undergraduate Research Fellowship is a flagship program for us, which we piloted in 2021 with Columbia University. The first cohort had about 26 students, overwhelmingly positive response. So this year, we've quadrupled the program, expanded it from Columbia University to also include USC on the West Coast and Georgia Tech in the Southeast. 110 SURE fellows are now enjoying this program. I just met some of them last week in Columbia. The energy and the enthusiasm of the cohort there, the exposure to top-tier research institutions, et cetera, is just delightful to see. And it's opening up their minds to new possibilities, what they can do. I invite all of you to follow the progress of this program on the Amazon.science website. This is a website where we put out a lot of science blog posts as well as programs like these. One more thing that I will mention is the massive multilingual data set. This is the largest parallel language data set for conversational language understanding that has ever been put out, 51 languages with 18 domains and 60 plus intents that are fully annotated. Tens of thousands of downloads within the first few weeks of it being launched. We're seeing global interest in this. There's also a competition that will be held at EMNLP in Abu Dhabi later this year. EMNLP, for those of you who may not know it, is one of the premier language processing conferences in the world. And so there will be an open competition for people. This will advance the state of NLP for many, 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 many languages. So our hope is that less commonly taught languages will also advance with this initiative. Lastly, Alexa Fund investments. The Alexa Fund provides funding to startups. I'll mention a couple here that you will see out in the tech showcase. Fiddler, which works on transparent, explainable AI, is in the tech showcase. VoiceIt develops technologies for speaking challenged users. Embodied AI, Moxie, you probably saw the robot if you've been to the showcase already. All of these initiatives are also focused on trying to advance underrepresented founders. In fact, 3 or 4 of these, Agenta, Define.ai, et cetera, are all with women co-founders. And we're very proud of our partnership in that initiative. Now on to the third pillar, advances in AI and machine learning. The key inventions that open up new possibilities for AI to be more inclusive and accessible. And Michael.
Great, thank you. You've made me scared of this thing now, so I'm going to treat it very gingerly.
Just don't wave it with your right hand. So.
Okay, so I just want to take a few minutes to talk about the area that's come to be called responsible AI. And I'm going to break it into sort of 3 subsegments. First, I just want to give you a whirlwind taste of what the underlying science of this looks like. And there's actually by now quite a bit of science really that's just developed in the last 7 years or so. Then I want to make a few remarks about how my view of that science has been altered by the time I've spent at Amazon and the realities of applying those scientific ideas in fielded product services and the like. And then I want to end with just some remarks about what this means for the future of responsible AI, both on the research side and on the practical side. So responsible AI, the science. So to date, the science of responsible AI has largely focused on the topic of fairness, and specifically the topic of fairness in trained machine learning models. And to decipher what I mean by that, largely speaking, the types of fairness definitions that people have studied are what you might call group fairness measures. And so the goal is to both audit or detect biases in trained model and then to mitigate them as well. So concretely, for example, we might be building, let's say, a speech transcription system. And in addition to being concerned about its overall accuracy and performance population-wide, we might, as a matter of fairness, want to make sure that that model or system works equally well on different regional accents and not just on the most common regional accents. Okay, so we're looking for some kind of performance parity, or in a consumer lending application, you might think that false rejection is a harm, denying a loan to a creditworthy individual, and you might want to make sure that the false rejection rate on men and women is approximately equal. So much is known about these types of fairness definitions and how to enforce them algorithmically. I'd say it's quite early days from the perspective of sort of wide-scale commercial deployment. I think that's partly due to the uncertainties of the current regulatory landscape. So on the one hand, the science of responsible AI has proposed very concrete notions of fairness and how you would audit for them and how you would train models to mitigate those types of biases. On the other hand, modern technology and algorithmic regulation and legislation talks about fairness but doesn't say exactly what those words mean. And so there's a gap between the science and the language of regulatory documents that I think will shrink over the coming years. There are also some realities behind responsible AI, which is that often it doesn't come for free. Sometimes there can be, for instance, trade-offs between fairness and accuracy in trained models. So I'm actually showing you an empirical plot on a real data set. The blue and the red correspond to different training algorithms, and each one of those dots corresponds to a different trained model. And what I'm really showing you here is what an economist might call the efficient frontier. On the x-axis is the overall population-wide accuracy of the models, and on the y-axis is some measure of the unfairness of those models. And so you see, if you just say look at the red curve, that you could choose the model with the smallest overall error, which is the leftmost point in red near the top, but that has the highest unfairness. At the lower right, you can get down to zero unfairness, but at the cost of much higher accuracy. And these types of trade-offs are inevitable in certain cases, and so the sort of extra scientific problem to manage is to sort of decide where you want to be on that spectrum. I'm focusing here on fairness just for concreteness. There are a lot of other emerging topics, things like privacy-preserving machine learning. How do you train models in a way that isn't just performant, but also makes sure that the parameters of the trained model don't leak or exfiltrate sensitive training data that went into the process? Okay, so up until a couple of years ago, the slide that I just described was largely the world I was living in academically as a card-carrying member of the machine learning community, thinking about technical, scientific aspects of things like fairness and privacy. In spending time at Amazon, I've realized that the reality is a good bit more complex in a number of ways, and I'll just give you a few examples. So one example is that, of course, if you've trained a model on some large data set and you're concerned about fairness, you should audit the trained model on that same data set to make sure, for instance, that across different groups the performance isn't wildly different. But often, you're building something that is not the final product, and there's going to be some downstream use case. So again, I'll use speech transcription as an example. You might do everything that you can do, so to speak, in the laboratory to make sure that your trained model is performing approximately equally across different regional accents, for instance. But a customer might use that model in some setting that you didn't anticipate. For instance, an acoustic environment that you didn't anticipate that has some systematic kind of background noise that was different than the background noise that you deliberately tried to train the model in. And so you have to kind of think not just about performance and fairness on the data that you train the model on, but on other data sets and other conditions that you didn't anticipate. And this can often lead to challenges of just curating and annotating data. If there's some regional accent on which you're not performing as well as you would like, and you need to get more data on it, that can be an expensive process. You need to go out and find native speakers of that regional accents and have them speak in different acoustic environments, and then actually have human beings annotate and transcribe the data, all of which, of course, is expensive and time-consuming, but there's no other thing to do in many circumstances. It's even a little bit more complicated than anticipating downstream uses of your product by customers, for example. We live in an era of what I consider to be healthy, what I call AI activism, where anybody who wants to can get access to a commercial or open source API of some trained model or system, curate their own data set, and perform an audit on it, okay? And I'll say a little bit more about this on the next slide, but this is an even wider set of circumstances that one wants to consider, and this makes the problem even more difficult. On the more scientific side of things, the examples I gave in speech transcription or, let's say, consumer lending, it's quite clear perhaps what the groups that you're trying to protect are and what it is that you're trying to protect them for. But especially in a lot of the modern, unsupervised, complex models we're seeing, like large language models, it's not even clear what you should be auditing for in the first place. And I'll just give a few examples. I'm going to just show you 3 separate instances of a not even latest generation so-called large language model. You can think of the particular application that I'm showing you here as like autocomplete on steroids. So what I typed into the system was the thing that's highlighted in boldface, which is, despite their long history of disagreements, Chris decided that. So I just made up this sentence fragment, and the rest of the text here was auto-generated. And one thing that I invite you to notice is how good it is grammatically. And I'm going to show you 3 examples, and in each one of them, Chris is interpreted as male, even though Chris in general is an ungendered name. Okay? So there's, on the one hand, some sort of cosmetic superficial bias that's obvious here. It's not really clear how to eradicate it. You could do it for Chris, but Joe is often an ungendered name as well, and you don't want to be doing this piecemeal for every one. But you'll also notice that the content of the text that's been auto-completed here is actually quite emotional, subtle, and kind of rich. And so depending on the application, you may or may not want that kind of richness and subtlety to the generated text. And so you can see this one. Here's another one. Somehow the prompt that I gave often seems to elicit autocomplete text that has to do with relationships and whether they're going well or not. And so, in addition to just the more cosmetic, straightforward auditing for instance, gender bias in autocompletion, there are all kinds of other things that one may find objectionable or undesirable about different types of autocomplete text depending on the context and the use case. Okay, so what about the future? So, and I'll focus mainly on the science here. So there's a lot of work going on right now that's in very, very early stages about trying to address these problems of anticipating downstream use cases that you might not even have data on. So people are talking about building machine learning models that will be fair sort of under a wide variety of data sets or data conditions. People are now starting to talk about how you would audit for privacy and robustness. This is relatively obvious in the fairness case. It's not obvious how to audit a model or a system for a given privacy property or robustness property. On this, and I'll just close with a remark that on this issue of AI activism and people being able to perform external audits, an idea we've been playing around with at Amazon is the idea of bias bounties for crowdsourcing fair and accurate ML, where you, similar to bug bounties in software and security, instead of asking people to find bugs in your software, you've asked them to find bias in your trained models in a way that you can repair and ingest. And the little screenshot here is just showing an example from an experiment I ran in my undergraduate class at Penn in the last spring, where a team has gradually found a bunch of demographic groups on which they can improve the system's current performance, and then there's sort of a principled algorithmic way of ingesting those improvements into a better ensemble model. And I'll turn it back over to Prem now.
Thank you, Michael. Super fascinating how much ground you covered in those 3 slides. Very informative. This notion of bounties builds upon this instinct that we have that we need to bring a larger worldwide community into the process of developing fair, inclusive, accessible AI. But from that view of what's going on in the past and the future, let me give you a bridge into the current in terms of what we're doing with Alexa. So Michael talked about large language models. Our version of it is the Alexa teacher model. If you saw the keynote this morning, Rohit talked about our focus being on multitask, multilinguality, and multimodality, and the Alexa teacher model embodies all of that. The objective function we're optimizing for is to maximize the performance benefit across a broad set of languages worldwide, not just the sheer size of the model for one specific language, right? Debiasing, which is even after you train these models with all the data that you have, et cetera, they still exhibit the biases that were learned from the data. So how do we debias these models before we put them into production? This is where Michael's talking about how do you even do the auditing. So there are 2 aspects to this. One is the metrics, and the other are the techniques for debiasing. We're working on both of those we're working on metrics that are automatic so that they can scan the full surface area of all the customer traffic, customer interactions that we see. And then from that, shine a spotlight on where the defects are accumulating so that we can address those. Lastly, I'll just mention on the speech thing, in a previous slide, I talked about adaptive listening. One of the particular challenges that we're focused on the speech recognition front is that of disfluent speech. People who might pause while they're speaking, rethink, reword, sometimes stutter. A substantial fraction of people actually suffer from this. We've been investing a lot in improving the performance for that cohort of users. So adaptive listening on Alexa, a little bit of a deeper dive into it. 10% of Americans have some sort of communication disorder, a speech disfluency or a language disfluency of some kind. Millions of customers, a subset of those, stutter. We recently introduced this adaptive listening feature on Alexa. You can see that on the slide there. Makes it easier for people with those disfluencies and challenges to interact with Alexa. Once it's enabled, adaptive listening gives the user more time to finish speaking, but it's also better at recognizing the speech that people can't fix, like stutter. They're going to stutter. So we have to figure out how can the AI help overcome the barrier to improving performance on those. We combine things like more relaxed endpointing and also deep learning-based work, all of which is foundational to our North Star of an ASR that's equally performant for everyone. So let me just give you a quick peek under the hood of how we improve speech recognition performance for folks who stutter. Deep learning-based context classifier to find where is this disfluency happening in the speech, and then techniques that learn how to handle that thing adaptively for each customer, learning new parameters on the fly, improving performance for them. You can look at our publications. Again, I ask you to go to amazon.science. All of our publications are listed there. 300% relative 3x reduction in the word error rate for folks who stutter. We're really proud of this work because it cannot be justified by any ROI analysis. It's justified by the fact we want it to be equally performant for everyone, and we know it will improve performance for everyone in some way or the other. Last, as I bring this talk to a conclusion, a peek into the future with embodied AI. As we think about mobility-centric devices like Astro, which hopefully you saw in the keynote this morning, in combination with advances like Teachable AI, we can break down even more barriers to access in this mobility-centric world, helping adapt these things to different homes, to different users, etc. For those of you who might have missed this video at the keynote.
This is the backyard door. Yes, the door is open. I'll go close it. Thanks, buddy.
Okay. So imagine a world in which Astro learns everything about your home, or you teach it. All of that is resident on Astro, so your privacy is respected. You teach it this is your dining table. You teach it this is your dog, and you want it to find where your dog is. And it can come back and tell you your dog's next to the dining table. That's the future that we envision for people who might be mobility challenged or just need it for everyday convenience. I'll wrap with this story that has stayed with me since my early days of joining Alexa. This is Caden, the child that you see on screen. Cerebral palsy, is severely challenged. In fact, the only mobility he has is the movement of one finger, which he uses to activate his Dynavox device that allows him to communicate in some limited ways. He's also vision challenged. Throughout his life, as a toddler working with some toys, he's never had independent interactions. So while his parents were at a movie, Caden used his Dynavox device to somehow use the far field aspect of Alexa to drop in on his grandfather and ask him to come give him a ride. And that was Caden's first independent interaction since he was a toddler. Brought tremendous delight to his family. It also brought tremendous satisfaction to those of us who are working in this area, because this kind of impact on one life inspires us way more than reducing the word error rate by 10% relative for like a large cohort. So I will just leave you with this story that has stuck with me. Thank you all for your attention, and I hope you enjoy the rest of this event.